Now we can go into the infrastructure of basically like what makes this decentralization actually work. So the fundamental layer that makes the structure decentralized is the blockchain. So a blockchain is basically a public database or ledger that is updated and distributed across many computers in the blockchain network. So each block contains records of a number of transactions, and these blocks of data are stored on nodes. Since nodes actually like store the data of the blockchain, they're the infrastructure on which it all runs. Nodes can basically be any kind of device, mostly computers, laptops, or even bigger servers, and can basically be hosted by anyone with an internet connection and computing power. So all nodes are connected to each other and they constantly exchange the latest blockchain data with each other so that they all stay up to date. This makes the system distributed and all of them able to like confer on like the accurate data that's stored across the network. Basically, and then, oh, sorry, still back on that one. Yeah, so a block is added to the blockchain using a consensus protocol called proof of work. This is basically where a miner solves a computationally challenging problem in order to add a valid block to the chain. If the work is validated, then all of the nodes will, all the block will get appended to all of the nodes' copy of the ledger. And yeah, basically in this way, the blockchain is completely transparent and distributed. It's also immutable in the fact that like once any data or block is appended to the blockchain, it is impossible to be altered due to a cryptographic method called hashing, in which basically every block that's appended gets a unique hash and has a reliance on its parent's hash in order to link all of the blocks together. So if any data is altered, it would basically cause the hash to be needed to be recalibrated, and therefore every subsequent block's hash needing to be recalibrated, which would be basically impossible and gets vetoed before any inaccurate data can get appended to the chain. So yeah, basically in practice, this structure is used as a secure and transparent way for people to exchange value, like money, services, or products, without having to trust a single party with their information or money, as the transaction is basically handled completely in code. Cool. So moving on to Ethereum's blockchain, which is what we're mainly going to be focusing on. Basically, Ethereum was imagined out of the initial conceptualization of the Bitcoin blockchain. It basically was imagined in 2013 when its developers coined it the world's programmable blockchain. It basically strived to take, sorry, let me, it basically wanted to imagine Ethereum being able to use the blockchain in the same way that Bitcoin was able to like do a financial asset. Sorry. The idea for Ethereum was that in the same way a financial asset like Bitcoin could benefit from decentralization, many other types of businesses and agreements would benefit from getting rid of the middleman and creating a transparent record for all to see. Basically, it would utilize blockchain technology far beyond like just the application of digital currency, but instead also in applications such as like gaming industry, lending and trading, web apps, and digital art. So yeah, the way that Ethereum has managed to basically apply blockchain technology to reach way beyond the financial sector in this way is with the advent of smart contracts. So yeah, smart contracts basically consist of code that specify predetermined conditions that when met, they trigger certain outcomes. They're often used on the Ethereum blockchain to automate the agreement and execution of transactions and negotiations between multiple parties. Basically, this script or like part of code can say that like once something happens, then you can be certain that like money will be exchanged or services delivered, content can be unlocked, assets transferred, or a lot of other types of data manipulation. So those who are familiar with like programming, it's basically an if-then statement or an asynchronous function that basically like when an event is triggered, it will execute some outcome. Yeah, so smart contracts definitely like revolutionize the space of blockchain and like what applications can be done using blockchain technology by just making like way more use cases possible, such as like, you know, if I were renting an apartment from someone, they could basically like verify via a smart contract that I pay them, and then only then like, you know, send me a text with like the code to my apartment or something like that. So anyways, and there's like thousands and thousands of different applications that we'll get into later of how these smart contracts can be applied. But yeah, to understand smart contracts though, basically oracles are the thing that makes them practical and actually able to be used in the real world. So they're essentially a form of communication between the outside world and the world of blockchain. Oracles act like an API between, yeah, like I said, like the outside world, like off chain and on chain. The problem before was that if smart contracts wanted to access outside data, they would basically have to maybe like use an API that maybe connected to like Bank of America or a different financial or anything, like any API that just connects you to outside data and be authenticated to that. But that created like a centralized point in the smart contract, which would then like defeat the whole purpose of the smart contract being decentralized. So oracles are basically an on-chain tool or API that allows smart contracts to access like real world outside off the chain data from on-chain, if that makes sense. So yeah, anyways, that was a quick overview of like all the basics of the infrastructure of DeFi. Now we're gonna go over the application. So yeah, I'll hand it off to Ezra.